Greetings to you, good people, and welcome to today's lesson. Before we continue with today's lesson, we wish to first of all thank you for always being there and to appeal to help us so that we can support underprivileged learners in local communities. We really count on you as you support this humanitarian endeavor. By the end of the lesson, you're going to find a link through which you can watch the full detail on this project. In today's lesson, we're going to be focused on semicircles and concentric circles. What is a semicircle? This is simply half of a circle. Concentric circles are circles with the same center and different radii. By the end of the lesson today, you should be able to calculate the area of a semicircle as well as the annulus. We have a semicircle here, and these are concentric circles. Where we have the dots or the shaded area is what we call the annulus. We have a bigger circle and a smaller circle, and the outer circle has a longer radius, which is here in blue, and the smaller circle has a smaller radius. So this is all we are going to be talking about in the course of our lesson today. The first aspect we are going to be looking at today as far as semicircles and concentric circles are concerned is the area of a semicircle. We studied circles last week and we looked at the different aspects of a circle. A semicircle is half of a circle. So it is common sense to know that if you want to calculate the area of a semicircle, you simply find the area of a circle and divide by 2. So that we're going to state the rule, then look at some examples so that we can better understand how to find the area of a semicircle. The rule states that area is equal to pi radius squared, which of course that is the area of a circle, divided by 2, because semicircle is half of a circle. Example, calculate the area of this semicircle, and this is the semicircle. Area A is equal to pi radius square divided by 2, and we substitute pi is equal to 22/7, and here we have not been given the radius, but we've been given the diameter. The diameter D is equal to 14 centimeters. Therefore, radius is equal to diameter divided by 2. That is 14 divided by 2, which is equal to 7 centimeters. So our radius is 7 centimeters. With this, we can substitute pi 22/7 times 7/1 times 7 again over 1. This 7 can simplify this, and 22 times 7 is going to give us 154. This is not the final answer because we are supposed to divide the answer we have by 2. 154 divided by 2, which is going to give us 77 centimeters square. So this is our area of this semicircle. If this is understood, then we move to the next aspect, which is area of concentric circles. B is area of annulus. And the rule, first of all, before we state the rule, let's understand what an annulus is. Annulus is this area between the inner circle and the outer circle. So for us to find this area, we have to calculate the area of the outer circle and the area of the inner circle and find the difference. So here our rule will be area of larger circle minus the area of the smaller circle. Concentric circles form the annulus. The example states, what is the area of the shaded part in these concentric circles? Now the outer circle has a radius 10 millimeters and the inner circle has its radius 7 millimeters. So let's start with the larger circle. Area of larger circle is equal to pi radius square. Let's substitute. Pi is 22/7 times the radius here is 10 millimeters. 10/1 times 10/1. 22 times 10 times 10 is going to give us 2200 divided by 7, and this will give us 7 here, 1, 7 into 22, 3 remainder 1, 7 into 10, 1 remainder 3, and 7 into 30, 4 remainder 2. So that our answer will be 314 and 2/7 millimeters square. You can put it in fraction form or in decimal form. So that is the area of the outer circle. Let's go into area of the inner circle. Area of smaller circle the rule is pi radius square. So we denote this one with small r to differentiate. It's the smaller circle. And we substitute just as above. Pi is 22/7 times radius here is 7. 7/1 times 7/1. 7 can simplify 7, and 22 times 7 is 154 millimeters square. We've had the two areas, that is area of the bigger circle and area of the smaller circle. So our annulus, therefore, annulus will be equal to 314 and 2/7 minus 154. And this is going to give us 160 and 2/7 millimeters square. That's just it as far as annulus is concerned. If you understood this for concentric circles as well as this for semicircles, then you've learned something today. Follow up with us as we are going to go into irregular shapes, shaded portion in our next lesson. Do not miss this because it's going to be very interesting as well. Until then, it is goodbye from us.